All right. Good afternoon, class. I am in a meeting today, but I did not want to leave you without getting the notes. This week we're talking about chemical reactions and changes and reviewing physical changes as well. Now, throughout the week, we're going to look at different examples of chemical reactions and see if we can identify them by the indicator of change. Before we do that, we're going to be completing Cornell notes today. So you will get your copy of your Cornell notes from your substitute. We're going to go through them together. So even though I'm not here, we're still going to be able to do the notes. Feel free to pause the video if you need to as we go. Okay? The topic you can see at the top of your page is chemical reactions. And the essential question we're hoping to answer today is, how does matter change chemically? So later today, you'll go back and do your summary, and you can think about how does matter change chemically and what are some indicators of that occurring, okay? We're going to be working on just this side of your notes. We'll fill in one thing over here as well. But when you're done, you need to go back and figure out questions to ask. So you're not done when you're done taking notes with the video. Does that make sense? You still have some things on your notes you need to do. I'll be checking them tomorrow, okay? Alrighty, let's get started. So look at the top of your page where it says changes in matter. That's where we're going to start today, okay? Changes in matter. Matter can change physically and chemically. Okay. And I'm going to try to fix this so you can see the best way possible. Oh my goodness, sorry. Bear with me for a second here. Okay. There are two types of changes in matter. Physical. So physical. During a physical change, no new substance is formed. That's kind of the first thing about physical. You have the same substance, you're just changing it in some way. These changes are reversible. So examples of changes can be changes in size, shape, or state of matter. So there are many ways you can change an object. It hasn't changed chemically. Its chemical composition is still the same. So even if we fold a piece of paper, though the paper's changed in size, it's still paper. Okay, so these are examples of physical changes of matter. No new substance is formed. You still have the same substance, and all changes are reversible. All the same. Okay, chemical changes, completely different. During a chemical change, a chemical reaction occurs. And this chemical reaction causes the actual chemical change. So a new substance is created during a chemical change. You have something with a completely different chemical composition. You start with substances, a chemical reaction occurs, and you end with new substances. So the molecules that have undergone the chemical reaction in the reactant interact to form new substances. This is an irreversible change. You cannot go back from this. Okay? The example your close reading gave you was a candle, a burning candle. And we're going to look at that same example again today as we continue kind of talking about changes in matter. So right now, you should have all of your places filled in under changes of matter, number 1 on your Cornell note sheet. Let's talk chemical reactions. Chemical reactions have products and reactants. Reactants refers to the left side of the equation, and we'll talk about what that means in a second, but we're looking at the left side of the equation. Products. This is the right side of the equation. Atoms rearrange to form new substances, new bonds to make new products. Okay, so let's take a look at what we mean by that. This same equation was on your close read from last week. So a lot of us had trouble with our summaries on this section and maybe missed the main point. I asked you about how was a candle an example of a chemical reaction, and some of us were still missing some information. So we're going to take a closer look. Okay. This is where, for the first time, you're going to write on the left-hand side of your note sheet. Okay? So far, we've done the top here. There's a big box on the left-hand side next to the picture we're going to discuss now. Okay? And that's where you're going to write. So, here we go. On the left-hand side, next to your picture, I want you to write example of a combustion reaction. Release of energy in form of light and heat. A candle burning is an example of a combustion reaction. What does that mean? That light and heat are released as a result of the reaction. We're looking at the actual picture of the molecules, so you can think about this as a candle is burning. This is what happens as a result, okay? An example of a combustion reaction. Release of energy in the form of light and heat. All right, so on one side of our equation, we have the products. And this marker's not going to let me do it, so let's try this over here. This side of the equation, this is the products. And on the opposite side is the reactants. Okay? All right, awesome. I'm sorry. This side is your reactants, and on this side is your products. Just kidding, okay? So the reactants are what you're starting with that have the chemical reaction. The two things, when they get together, they chemically react, and the products are what are created as a result, okay? I'm going to put some things up on the board I don't want you to write, but I wanted us to take a look at together, okay? So for a candle, you're starting with methane, CH4, and that's here. One carbon atom chemically bonded with 4 hydrogen atoms. This is methane. This is what the candle is made of, the candle wax, okay? And the great thing about methane is it's highly flammable. That's one of its chemical properties, with oxygen. So we have the candle wax chemically reacting with 2 oxygen molecules. And we've talked about how the oxygen we breathe is 2 atoms of the element oxygen chemically bonded. So we have 2 different oxygen molecules here. So when you light a candle, this is what it's reacting with. Okay? Now the arrow here indicates a chemical reaction occurs when you combine these 2 things, the candle wax and oxygen, and you have something to spark a reaction. In this case, the flame that you light to light a candle. Okay? You get a chemical reaction to occur, and this is a combustion reaction. Releases energy in the form of light and heat. Does that sound right for a candle? So you end up getting light and heat created as a result of your candle burning. The products of that are carbon dioxide and 2 water molecules. 1 molecule of carbon dioxide, a carbon and 2 oxygens chemically bonded, and 2 water molecules, hydrogens and oxygens bonded. Okay? Now the water we see in form of vapor. And so the carbon dioxide and water vapor that we see as a result of this reaction, you see in the form of the smoke coming up from the candle, okay, when a candle burns. So these are the things created as a result. Now you don't have to write this, but this is going to kind of help you with your lab tomorrow. Okay. If we looked closer at this chemical reaction, you would see that it is balanced. There's the same type of and number of atoms and reactants as there are in the products. The big numbers that you're seeing on your paper, like the twos, the big twos next to the oxygen in this case, and then the water over here, those are your coefficients. They tell you how many molecules there are. So we have 2 molecules of oxygen and 2 molecules of water. Okay? The small number we've talked about before, that's your subscript. That tells you how many of a certain atom you have in that molecule. 4 of hydrogen here, 2 of oxygen, 2 of oxygen here, 2 here of hydrogen. Okay? So, what we're going to figure out now is this a balanced equation? What that means, when you have a chemical reaction, you have a certain amount of atoms and substances that go into the reaction. That's the reactants. Now, after a chemical change has occurred, you have completely new substances created. So in this case, we started with methane and oxygen, and we end up with carbon dioxide and water. Okay? That's how we know there's a chemical change. Irreversible change, new substances created. Now the crazy thing is, we haven't created any new atoms or elements here. They've just rearranged themselves. And let's prove that here. All right. So again, we have our reactants and our products. If you take a closer look at this chemical reaction, let's take a look at the reactants first. The number of carbon you're starting out with. There's no small number next to the carbon here. That means we're going to have 1 carbon to start. Okay? Number of hydrogen. Well, I only see hydrogen here in the methane. We have methane and oxygen combining. And it says H4. So the amount of hydrogen we have is 4. Wait, let me just do it that way. Ignore that because this board's being awful. The number of oxygen. You have 2 molecules of O2, oxygen. So totally you have 1, 2, 3, 4 oxygen atoms. So 1, 4, and 4. Okay? Go to the other side of the equation. We have completely different substances, 2 completely different substances created as a result of the chemical reaction and the burning. We've had light and heat released, an example of a combustible reaction. Okay? So let's count the atoms on this side. Carbon. So we have carbon dioxide and water. We still only have 1 carbon, and that's CO2. Number of hydrogen. Now we have 2 atoms of H2O, or water. So let's count how many total hydrogen we have. 1, 2, 3, 4. Because we have 2 molecules of water, each containing 2 hydrogen. 2 times 2 is 4. Oh my gosh. That's a 4, in case you're wondering. All right, oxygens. Now, we have oxygen in 2 places in our product. CO2 for carbon dioxide, so we have 2 here. Okay? And then we have 2 water molecules. 2 here. So total we have 1, 2, 3, 4 atoms of oxygen. All right. Notice that even though we have completely different substances on either side of this equation, you have the exact same amount of atoms of each element, okay? You start with 1 carbon, you end with 1 carbon. You started with 4 hydrogen, you started with 4 oxygen, you end with 4 oxygen. So we're going to start talking about this a little bit more after we talk about chemical reactions and we kind of work through this. But this is an example of the law of conservation of mass. In a chemical reaction, you end up with the same exact amount of each type of atom on each side of the equation. So even though we have new substances created, we have the same amount of our original atoms. Okay? We're almost done. So you didn't really have to write anything here. I just wanted you to watch. Excuse me. We're going to move on now to indicators of change. There are 4 indicators that you read about for indicators of chemical change. And then we're going to look at what is the type of energy in a chemical reaction. So the 4 types, the indicators of chemical change, you should already have these. The first one is the production of a gas. This is an example of a chemical reaction. Now, an example you may have seen before, if you combine vinegar and baking soda, you have a gas created. You see it bubble, okay? Bubbling is an indicator of a chemical change, and that gas created as well. Same thing with a burning candle. You have smoke created as a result of that burning candle. So we have heat, and we have that gas, okay, of water vapor and carbon dioxide created. Formation of a precipitate. So an example would be combining milk, vinegar, and baking soda. You start with something liquid. After it chemically reacts, you end up with a solid. Now, normally if you started with a liquid and went to a solid, you'd be looking at a physical change because it's just a change of state of matter. But because you start with 3 substances and they combine to make something completely new and form a solid, this is an example of a chemical change because you have a new substance created. Color change and temperature change. An example of color change. If you combine iodine and starch, the 2 start, so iodine is kind of a brownish liquid you might have had put on a cut or like before you're getting a shot at the hospital, all right? And starch, when the 2 combine, they make a thick black paste. So color change is a clear indicator of a chemical reaction. And finally, temperature change, a change in heat, okay? A candle burning, it produces heat. This is an indicator of chemical reaction and chemical change, okay? And that leads us to our last point, the energy in chemical reactions. Now, there's 2 types of energy in chemical reactions, endothermic and exothermic. An exothermic reaction releases heat. So you can actually feel the heat coming off of an exothermic reaction. So would a candle be an endothermic or exothermic? Think about it, okay? Endothermic absorbs heat. You can actually feel things cool down around an endothermic reaction. All right, that's it for notes. As far as with me, here's what you need to do. Go back, and on this side of your page, you need to write your questions, okay? So if you folded your paper and you were trying to study for our next quiz, what would the questions you would ask yourself be besides, okay, what's an example of a combustible reaction? Be able to explain that. We already did that one. What other questions would you ask yourself about the 4 subtitles? So changes in matter, chemical reactions, indicators of chemical change, and energy in chemical reactions. That's 4 questions to come up with, okay? And finally, your summary. You need to write your summary. think about answering and addressing your essential question, look back over your notes. Your summary should tell you the things that if you were going to explain your notes to someone new, what would you want them to learn from them? Okay? I hope you have a good class. So your sub will give you some time to finish, and then you're going to watch a little video. Okay? I will see you tomorrow.